this next part is really important for getting to next week, which is all about reflection, refraction, diffusion, all these things that light is going to do. And that is this idea that a wave is a disturbance. And we're going to look at the process of reflection in order to kind of understand the bigger idea that a wave is a disturbance in a medium and how that works. Okay, so we have this string, and the string connects the beads. If this was just a set of beads and we moved one, the rest of them would have no other reason to move. So in a medium, there is something that causes, when one thing moves, it causes the neighbors next to it to move. As we look at the pulse wave of Zara sending a pulse down to Nick, and Nick is going to hold this quite still, the way it goes for most of the particles, I'm just going to read this, the way it goes for most of the particles as it goes down the string is, hey, my neighbor is starting to move up. I am attached to my neighbor, so he is pulling me with a force. That is also giving me energy. I guess I will have to move as well. When I moved up, I had to drag my neighbor with me. I'm giving my neighbor some of my energy. Well, my neighbor to the left is at the peak of the wave. He gave me his energy. Now I'm at the peak of the wave. My neighbor to the left is relaxing. I guess I will follow him and relax and give my energy to the next bead to the right so that they can see the awesome view from the peak. And that is how it goes until I've given all of my energy to my neighbor to the right. Okay, my neighbor, let me go back. This is to the left. I am attached to this neighbor. I moved up. I have to drag my neighbor to the right with me. Okay. So that's how it works for most waves, for most of the beads on the string. Most of the beads on the string get that. Get to do that. They get to pass their energy. The wave comes along and they pass their energy to their neighbor until they are all done with their energy. They got some energy, they went up to the peak, they came down, they passed all their energy away. But look at what happens to this last green bead. This last green bead has no opportunity. There's nobody to pass its energy to. Nick's not going to let it pass any energy to him. So what's going to happen? This is where it's really useful to think about this in physical reality. And that is, if this was a stretchy piece of rubber band and you pull it up, it's not going to snap exactly back to center. It's going to go below center if you have a fixed end. If you don't have a fixed end, this is like a rubber band lying on the counter, and I pick it up, it just snaps back to the counter. Right? If I don't have a fixed end, it just goes back to the normal thing. But if I have a fixed end and it's stretched across, it'll go up and down related to it. Okay. Now this bead right here, the one right before the green bead, it's going to try to send all of its energy. It's going to go up and it's going to send its energy to here. What force does Nick have to use to resist moving his arm up like a bead? He has to use an equal and opposite force, or his arm will move up just like the green bead would. So he's going to exert a force on this bead, an equal and opposite force. So what we see is it goes up, it tries to exert a force on this bead. When it does, Nick exerts an equal and opposite force, and we see that equal and opposite force here. That propagates back through all of these things, and we end up with an equal and opposite wave. Notice that the equal and opposite wave is going in this reverse direction, and it is now 180 degrees out of phase. If we take a wave that's going like this and a wave that's going like this, we add them together, they would cancel out just like we did above. That would be 180 degrees out of phase. When a wave is perfectly reflected, it is 180 degrees out of phase. This is going to turn out to be important if you're really interested in Rayleigh scattering. Okay. For the homework, there are some sections where it says you should stop here, take a break, and do the simulator a few times. So this is one of those times. You may want to stop the recording here and do the simulator a few times. And the instructions are right below. I'll put like a little symbol or something. I'll go back through and put a little symbol next to those so you can see when to do the homework if you're doing the recording. Okay. Doing the pulse, so I give you directions for how to do the pulse reflection. And then I give you instructions for how to make a standing wave. To do a standing wave, we're just gonna, to do a standing wave with pulse, oh, I forgot. Okay, so to do a standing wave with pulse is really simple. I just do this. I have a wave that goes down, it comes back, goes down, it comes back. The instructions I give for the simulation for you are about using an oscillator to make a standing wave. And for this, I recommend using slow motion, and it's kind of a little bit trickier, but I do recommend that you go through it. So press play, press pause, set the amplitude to 0, press play. It's a little bit messy. What you want to do, let me redo that. Let me restart. So press play. Oh, sorry, amplitude. Give it an amplitude. Press play. Restart. Come on. And I can slowly pace through it. Da, 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 until I get right back there. Set my amplitude to 0. Press play again. Okay, this is going to give me a standing wave that comes back through. It's reflected back through. The instructions I give on how to do this on the homework, to do this with the oscillating, it's a little bit difficult. It's more difficult than doing it with the pulse. But the reason why I wanted to do this is the standing wave. The standing waves, I said oscillation is more likely. It happens more in real life. Getting the standing waves going is much more like what you would see in a musical instrument. And this is going to be really important in our next, and I think our final 8 to 10 minute video of this, when we talk about resonance. And we're going to talk about Glenn's bottle flute. But I wanted your waves to look more like these guitar strings where we have oscillations. All right, I'll see you in the next little video clip.